Let's look at ketones now. Ketones have a lot of the same reactions as aldehydes, a lot of the same formation reactions, and a lot of the reactions that aldehydes undergo. Sometimes they differ slightly, so let's look at them separately. Ketones are like aldehydes in that they also form enols and enolates. So why don't you just go ahead and draw the enol of cyclopentanone and then the enolate of acetophenone. So here is the cyclopentanone enol, and the enolate of acetophenone would be this. All right, let's go on to the formation of ketones. Like aldehydes, we can do oxidation of an alcohol, except we have to have a secondary alcohol in order to form a ketone. We can do oxidative cleavage of an alkene. We learned how to do Friedel-Crafts acylation to form a ketone when we looked at the aromatic electrophilic addition reactions, and we saw that we could hydrate an alkyne to form a ketone, a methyl ketone. A new reaction that we're going to look at is using a Gilman reagent to add a carbon chain to an acid chloride. Remember, Gilman reagents were coupling reagents, and we basically can couple an alkyl halide to an acid chloride and give ourselves a ketone. So let's go through these old reactions to review them. We can take a secondary alcohol and oxidize it to a ketone. And I put just the general symbol for oxidation here because we can use PCC like we do with aldehydes, but we also can use chromic acid. You can't oxidize a ketone any further with chromic acid, so it works fine. Potassium permanganate will oxidize an alkene, so will ozone and zinc acid. Will oxidize an alkene, do oxidative cleavage. And if you have the carbon having two alkyl chains on it, you'll end up with a ketone over here. This is an example of Friedel-Crafts acylation. We take an acid chloride and use aluminum chloride. And remember, it causes the acyl cation to form, which then does electrophilic addition to a benzene ring. And then here's a terminal alkyne. It doesn't have to be terminal. You can have an internal alkyne. If you do oxymercuration, you end up making a ketone. Just be careful. You can't do this on an alkyne that would give you two different ketones because then you would have a mess afterwards. Here's the new reagent, the new reaction, using the coupling reagent, the Gilman reagent. And what we basically do is we take this alkyl chain and we couple it to the acyl part of an acid chloride, and it makes a ketone. Remember that Gilman reagents were used to couple an alkyl group to an alkyl halide. Well, this is like an alkyl halide. It's just got the carbonyl on the end. So it's very similar to what we learned before. Here's an example. This is benzoyl chloride, and this is a cyclohexane Gilman reagent. Notice it just takes that Gilman reagent and tacks it on in place of the chloride. So how can you do these things? These are a variety of reactions that we just went over. I want you to repeat the trying to form acetophenone under all these different conditions. So how do we form acetophenone from ethynyl benzene? Another name for that would be phenylacetylene. So how would you form acetophenone from ethylbenzene, also known as phenylacetylene? Well, here is ethylbenzene. How do I make acetophenone out of this? Well, this is acetophenone. What do I need to do? Well, that's hydroxymercuration. There are the conditions I need. How do I form acetophenone from 1-phenylethanol? Well, here's 1-phenylethanol. Here's acetophenone. What do? I oxidize. And you can use chromic acid here, or you could use PCC. It's up to you which one you choose. And also what other functional groups are on your compound that you might affect conditions. How do you form acetophenone from 2-phenylpropene? Well, here's 2-phenylpropene, and here is acetophenone. There are the conditions that we need to use. It's oxidative cleavage. We cleave the double bond right there to form the ketone. How do I make acetophenone from benzene? Here's benzene. Here is acetophenone. To do that, I do a Friedel-Crafts acylation. How do I make acetophenone from benzoyl chloride? Well, here's the benzoyl chloride. Here is acetophenone. The conditions that I need to use are the Gilman reagent.